Namaste and welcome everybody. Today we have a presentation in our TAE seminar series. It's about an evaluation of LLMs for generating movie reviews with the comparison between GPT-4o, Gemini, and DeepSeek. And we have Brandon Sen, Zining Wang, and Chen Hao who will be presenting. But the paper is also co-authored by Yushuan, Zhao, and Lai Wei, and the paper is available on Archive, and this is part of a master's group of master's project at the School of Mathematics and Statistics at UNSW, and I was the supervisor for this project and also a co-author of this paper. Thank you, Brendan. You can begin.
Thank you, Rohit. As Rohit mentioned, this is a presentation on our research paper, which was an evaluation of large language models for the generation of movie review content. So this is the outline that we'll follow, which is pretty much similar to the outline of our research paper. So what was the motivation for the paper in the first place? Large language models are prominent in tasks today, including text generation and summarisation across a range of fields and topics. And this paves the way for their use in additional areas which can include the generation of movie review content. But there is a question outstanding relating to these large language models in relation to their ability to replicate human nuanced emotions which come with ingrained with cultural experience and knowledge. So the objective of the paper, we propose a framework that generates movie reviews using three prominent large language models, GPT-4o, DeepSeek-V3, and Gemini-2.0. And we evaluate their performance by comparing the generated outputs from these models with IMDb user review content, which is, of course, human-generated reviews. We use both movie subtitle data and screenplay data as the input for these models. Subtitle data is the information you see at the bottom of a movie if you're watching a foreign language movie, for example. And screenplays are the text that, for example, a movie producer would use when producing a movie. We assess the models in terms of vocabulary, sentiment, polarity, similarity, thematic consistency, and in comparison with the IMDb user reviews. So some background on this topic to understand why this area of research may be important and of interest. Firstly, we know that movies impact our society in various ways. They shape our culture, values, they influence global issues like climate change and gender issues and so forth. You can think of movies like Philadelphia or Spotlight as good examples of this. And movie reviews are interpretations or critiques of this movie content, and hence they also play a crucial role in shaping audience perceptions, and they influence a film's commercial success. Studies have shown that professional reviews in particular directly impact the success of movies at the box office. We know online platforms like Rotten Tomatoes and IMDb have democratized the review process such that reviewing is available essentially to the masses. But along with that, there are some problems with the world of movie reviews relating to things like the halo effect and the impact of rating aggregators, where early review sentiment can be magnified to the point where movies receive inappropriate review or rating outcomes. So what are the large language models that we're talking about? These models have experienced, as we all know, a meteoric rise in prominence in recent years. They show amazing levels of cognition, and what they are deep neural networks with many layers that are capable of returning meaning from vast amounts of data. They have a transform architecture, which means they have a encoder and decoder structure. And this table summarises the key features of the two prominent models that we use in this paper. Firstly, the BERT model, which uses the encoder component of the transformer. Its purpose is for understanding text or analysis and classification of text, and it's trained in a bidirectional method using masked word prediction. Whereas the GPT models are for text generation, conversation, and the like, or for chatbots. They're trained in a left to right format using next word prediction. So the framework that we used for this paper is summarised here in this flow diagram, which I'll go through in some detail. So the first thing we did, we had to collect some data for the research, and we did this by extracting data sets from Kaggle for movie subtitles and movie transcripts, and we also extracted IMDb movie reviews from Kaggle as well. Once we had this data, the subtitle and transcript data sets were quite messy in particular, so we had to do an amount of data cleaning. We had to remove timestamps and non-alphanumeric symbols and like to make allow the data to be useful for these models. We then created 5 different personas for use with the models, and that's I guess you can think of it as 5 different people, and the purpose of that is to try and get some diversity in results from these models when they're generating these reviews. So we plug these, we provide these 5 personas to the model. The models, we provide the clean data sets to the models, the transcripts and the subtitles. And then we ask each of the models, GPT-4o, Gemini and DeepSeek, to each produce a positive review, a neutral review and a negative review for each movie. So each model in turn subsequently generates 15 reviews per movie. Now, once we have the LLM generated reviews, we also have the IMDb generated reviews here that we extracted originally from Kaggle. And we can now do some analysis between these 2 groups of data. But firstly, what we had to do is filter out stop words, and we also had to, once again, remove non-alphanumeric symbology from the reviews, because for some reason these models like to use a lot of symbology in when their content is generated. So we went through that process a second time. So after doing that, we then conducted the following 4 analyses. Firstly, a trigram analysis where we generated the most popular or most common word triplets from each of the reviews. We performed a sentiment polarity analysis, which gave an indication as to whether the reviews had a positive or negative tone to the reviews. We conducted an emotion analysis, which extracted key emotion topics for the review content. And finally, we conducted essentially a word similarity analysis of the reviews as well. We did that using both the screenplays and the subtitle data sets, and we also went through this process using the 5 personas that I mentioned, but we also had another 5 personas which were a much more detailed description of these persons, if you like, to assess what the impact was of providing much more detailed or rich content to these models. And finally, we produced a questionnaire for people to answer, which was essentially a questionnaire to test people's ability to tell which reviews were AI generated and which were human generated. So that's essentially the framework that we followed. Just as an example of the personas that we used, the first one is, I guess, one of the simpler personas. Just 2 lines. You're a young woman who goes to the movies a lot and you enjoy providing honest, informative reviews. The second persona is far more detailed, and we're asking the person or the persona to consider the characters, the actor names, and emotional themes within the movies. So far more detailed input into these models in terms of the 2 types of persona groups. The key libraries that we used in doing the analysis for the similarity or word similarity analysis, we used a word vectorizer from scikit-learn, and a cosine similarity function was run over the results of the word vectorizer. For the polarity analysis, we used a Roberta model, which is I guess a more recent version of the BERT models that I mentioned before, and that was trained on a Twitter data set for that purpose. And for the emotion analysis, we also used a Roberta model, which had been pre-trained for the extraction of emotion themes. So I'm going to hand over to Ian, who's going to take us through some of the results that we generated in doing this analysis.
Here, let's move on to the result section. This is trigram analysis. A trigram refers to three words that appear together in the review, which is to compare the writing style of LLMs and IMDb users. From these two charts, we found that IMDb reviews often mention the names of actors, characters, or directors. GPT-4o and DeepSeek-V3 did this as well, like is Ledger or Immobile. But Gemini-2 used fewer names and relied more on carrier repeatable phrases like even get started. In terms of tone, GPT-4o was positive and descriptive. DeepSeek-V3 was more formal, and Gemini-2 was more emotional, especially in negative reviews. We also found that longer movie titles created more repeatable trigrams. For example, Crouching Tiger, Hidden Dragon led to more patterns than short title like Avatar. Overall, GPT-4o and DeepSeek-V3 produced reviews that sounded more natural and closer to what a human would write.
Hi everyone, in this part, I'll present key findings of sentiment polarity analysis and the emotion analysis section. We first conduct sentiment polarity analysis to evaluate larger models' alignment with different prompts. In this figure, GPT shows strong positive scores on the positive prompts and even on the neutral prompts. Compared to other larger models, it performs best on the positive prompts. DeepSeek shows closest alignment with IMDb reviews on the negative and the neutral prompts. In addition, larger models may amplify the sentiments like Gemini and Gemini details amplifies the negative sentiments, and GPT amplifies the positive sentiments. In this figure, we use both plot to compare the impact of different input types, subtitles and screenplays. Subtitles trigger more polarized sentiments, where screenplays exhibit more stable distributions. So we conduct emotion analysis across these 7 categories. According to table 5, GPT shows the highest joy score of 0.376. DeepSeek stable neutral with neutral score 0.328. Where Gemini and Gemini details are prone to more neutral and discuss. In contrast, IMDb reviews are stable balanced. So we conduct. So in this figure, we compare emotions across 6 movies. Larger model generated reviews generally are more discussed and neutral IMDb reviews. Crouching Tiger and Titanic stay more sadness IMDb reviews. Brokeback Mountain and the Shawshank Redemption shows more discussed IMDb reviews. This again validates that larger models may amplify the emotions. According to this figure, we compare emotions across various prompts. On the negative prompts, larger models generally perform well, and they concentrate more on disgust, neutral, and sadness emotion. On the positive prompts, only GPT shows a clear joy emotion, and other larger models concentrating more on neutral emotion. On the neutral prompts, larger models generally perform well, and they concentrate more on neutral emotion. Finally, this box prompt further confirms that subtitles can generate more extreme emotion, especially in joy and disgust emotion, where screenplays yield more stable results. In conclusion, larger models can generate reviews that align with both sentiments and emotions. GPT performs better to positive prompts, and it aligns well with IMDb reviews. DeepSeek stay more balanced and neutral, and it also aligns well with IMDb reviews. While Gemini performs better to negative prompts, and but it can be overly intense. Compared to IMDb reviews, larger model generated reviews amplifies sentiments and emotions. In addition, input text also matters. Subtitles amplify emotions, while screenplays offer more stable context.
Okay, let's move on to the similarity analysis. We use cosine similarity with TF vectors to measure how close LLM generated reviews were to IMDb reviews. We found that IMDb reviews were very diverse, so the similarity between them was usually low. Each review is focused on different things like character, story, or emotions. When we compared LLM reviews, we found that GPT-4o had the highest similarity. Its reviews were stable and most similar to human writing. DeepSeek-V3 came next, though its performance was less consistent. Gemini-2 had the lowest similarity score and sounded less like how people typically write. Input type also made a difference. Reviews based on screenplays were better than those based on subtitles because screenplays offered more context. We also tested the effect of persona prompts. We found that detailed prompt helped Gemini generate reviews that were more stable and reliable. We also found that negative reviews were more similar to IMDb reviews, probably because they were more specific and direct. Okay, let's talk about the quantitative analysis. We asked 50 participants to guess whether each review was written by a human or by LLMs. From these three charts, we found that some IMDb reviews were misjudged as LLM writing, especially when writing was simple. GPT-4o reviews were often thought to be written by humans because the tone was smooth and positive. Gemini-2 reviews, especially the negative ones, were easier to recognize as LLM writing because of strong or strange emotions. We also asked people to guess the emotion in each review. We found that GPT-4o showed more joy and Gemini-2 showed more sadness and disgust.
Okay. To summarize, we tested these three models, GPT-4o, Gemini-2.0 and DeepSeek-V3. We found they're all capable of generating reviews that are comparable with IMDb reviews. And they were able to effectively perform the task that they were asked to do, which was to produce a positive review, negative review, or a neutral review in a syntactic, fluent way. In terms of emotional expression, we found that GPT-4o and DeepSeek-V3 aligned very well with IMDb reviews. However, GPT reviews seem to overemphasize positive emotions, whereas DeepSeek seem to be more balanced in emotional expression. Gemini 2.0 seemed to capture negative emotions well, but was excessive in its emotional intensity. In terms of stylistic differences, one of the main differences was that the LLM reviews had fewer references to movie characters and actors, as we mentioned earlier on. Screenplay reviews seem to be have more stable output, and subtitle reviews were more emotionally volatile and expressive. We found through the questionnaire that the LLM generated reviews were were basically impossible to detect by human humans that were asked to sit that survey. And there was one of the, I guess, key stylistic problems that we did see is that the LLM models had a tendency towards what we call templated structure and lacked human-like spontaneity. And we'll see an example of that when we go through the GitHub repo and look at some of the actual review results. What are the limitations of what we've done here? Well, the first one is the limited number of movies that we reviewed. We only selected 6 movies, and that's likely going to cause issues with possible sample bias. So any future research, we would likely need to increase the number of movies that we're conducting analysis over. Content moderation of these models potentially affected authenticity, particularly in terms of negative expressions. And finally, the semantic analysis was quite a simplistic approach in terms of analysing word content between the different reviews. So a more in-depth semantic analysis could be considered for further work. So continuing with possibilities for future work, we could look at training these models using human-generated review data sets, i.e., essentially feeding in some IMDb reviews as content for these models to work with in production of their own review output. As I mentioned, a more complex evaluation, in particular relating to semantic analysis, is essentially necessary to get an in-depth understanding of the real contextual and emotional similarity of these models to human-generated text. And finally, the possibility of including multimodal inputs like videos, audio, cinematography could be a possibility, but that may be for quite some time down the track. So in conclusion, what were our findings? We showed that LLMs have strong potential for producing high quality movie review content that's well aligned with human-generated reviews. They still face challenges mimicking some of the emotional depth of human reviews, and the variation of human reviews versus the AI-generated reviews is also potentially an issue with, as I mentioned earlier on, the tendency for these models to have a level of templated patterns in how they produce their output. And there's possibly the need for enhanced emotional controls and more diverse training data to improve the outputs of our analysis. So I'm going to take you through the GitHub code base quickly to show you what we've done here. Just one moment. Okay, so So this is the GitHub repo for the project. So first of all, the data that we extracted from Kaggle resides in this folder here, data, and you can see there's two sets of clean data, one for screenplay content and one for subtitle content. Then the reviews that were generated. First of all, we've got the LLM generated reviews here and the IMDb reviews that we extracted from Kaggle. Now, if we have a quick look at the some of the reviews generated by these models, we look at Gemini here. You can see across the 6 movies here, it basically, the model starts the review pretty much well in a very similar pattern. And that's kind of similar with a number of these models. If we look at DeepSeek, DeepSeek has this pattern where it says movie review, the movie, and then goes into you know, quite a nice review, but there is a level of templating in the output. And that templating was actually picked up in the trigram analysis, where, for example, with Gemini reviews, the word "okay," "let's," or whatever it is came up in the in some of the top trigrams. So that's the actual generated reviews. In terms of the results of the analyses, they're all sitting in this folder here. We've got folders for each of the analyses: cosine similarity, emotion analysis, polarity analysis, the trigram analysis here, and also results from the questionnaire. And in terms of the key pieces of code used for generating this, all of this output, first of all, we've got some code that uses Roberta models for generating some of the output. This code here is for actually generating all of the review content by the 3 models. We've got code for the cosine similarity analysis we conducted, and code for the trigram analysis. They're the main pieces of code, and there's some additional helper code pieces as well. And that's all fairly well documented in the in this README file, if anyone wishes to go through the code base in more detail. Now, that, I think, concludes our presentation. So if there are any questions, we're happy to field them.
Thanks, Brendan and team, for an excellent presentation.
Thank you.
Right, so are there any questions from the floor?
Those and I'll speak probably, then you can hear me.
Sorry.
So my question is about the choice of the models that you have taken. There are various other GPT versions. There are a few other Gemini versions available. What made you choose these specific models for your analysis?
The specific versions of each of the models?
Yeah.
So we chose GPT-4o because that was essentially the model variant that seems to be used quite, or mostly used in research topics. there was actually a problem with that model in that the size of the content that we provided to the model was substantial. The movie screenplay text, for example, is for some of the longer movies is kind of 80,000 tokens long, which is way longer than I was actually able to use for that OpenAI model. But OpenAI were kind enough to give me an extension in the size of the input context that I was able to use for a brief period of time to conduct the research. In terms of the other models, well, DeepSeek-V3 is essentially the most recent version of that model. And that there were no issues with content or token size. And finally, Gemini, again, it's not the most recent model, but it's quite recent, and it was the model that we're able to use that could sustain the size of the input context.
Thank you.
I have a couple of questions, if it's okay. Can everyone hear me?
Yes.
Yeah, cool. Right, so awesome. Thanks for the talk. Really sort of exciting space to be working in. I had two questions and one suggestion. The simpler question is, so when you showed the examples of what the actual movie reviews from the GPT models look like, and you sort of discussed the fact that they appeared to be heavily templated, it did make me wonder whether when you got the human users to evaluate whether they were human written or GPT derived, were you careful to make sure the users didn't see multiple movie reviews from the same model, because it's possible that they would end up just detecting the template rather than the actual content?
Well, I think without doubt, if you see the full set of output, it would be easy to pick. I believe we basically randomly chose groups of review content from each of the models, but it was not enough for people to essentially draw a conclusion that, oh, hang on, there's a whole bunch of reviews that are starting off this way, for them to make that conclusion. And that was really because, we're asking people to read fairly lengthy pieces of text and draw conclusions on it, and you can't give them, 20 movie reviews and ask them to spend
Understood.
To do that.
But the random selection does mean they could potentially have seen multiple reviews from the same model, right?
Yes. Yes, it is possible.
Yeah. Okay.
Cool. Picked up on it doesn't seem that people generally picked up on any theme.
Yeah.
That's quite obvious when you see the full set of output.
Yeah, interesting. The other question was, so, I mean, it's really interesting when you show this work about the kind of, I guess, the distribution of sentiment and emotional and types of languages across the different models and comparing them. One thing I do wonder is whether it's worthwhile looking at something like because every model might have a slight bias towards being slightly negative or slightly neutral or certain kinds of language. But if you could convert it to a raw score or some kind of like an overall positivity, negativity score, and then look at the ranking of the different movies, because it'd be interesting to know whether the models ended up with ranking the movies roughly the same, even if the language they use or the kind of the emotional tonality was slightly different.
Right. Yes,
I don't know.
So
I guess with 6 movies, that's a bit difficult, though.
Yes, I think without doubt, any further work on the topic would require expanding the number of movies data sets we're working with. But that would be in that we did find that there were, as we mentioned, sort of tonal biases between the models. We mentioned that they seem to be more positive regularly and so forth. It would be interesting to see if they still ranked
the same.
Yes.
Yeah, it's interesting to see. So one final suggestion, I think, before you went full multimodal, I wonder whether you could just simply get a bit of an improvement by concatenating some text data today. So like if you're using the screenplay, but prefix it with, say, the studio pitch for the film, the casting decisions, a few of those kind of names and key ideas, like, you know, the recent films the director worked on, something that might kind of spice up, give the model basically a capacity to mention the actors used in the film.
Yes, yep, I think without doubt. Any access to any additional variant in data set, I suspect will be useful. And I think, you know, also providing, you know, the model with versions of IMDb reviews for it to essentially learn from as well may be of use.
Yeah. Cool.
I have another question, and this is just me trying to figure out how difficult this was for you. So you extracted the details from these 6 movies. You extracted the reviews from IMDb. How long or how tedious is the process? How easy is it to extend this to, let's say, 100 more movies, if you were supposed to do that?
Well, I don't think it's hard at all. Really, it's just scaling up the code that's already there. It's quite running all of the data sets through the models takes a long time. DeepSeek in particular is excruciatingly slow. I mean, to do 6 movies, it took, I think, at least a couple of hours to iterate through. So, you know, as long as you've got access to the appropriate levels of access to the APIs, and you know, it's just a matter of time to, you know, iterate through more data. So it wouldn't be difficult to scale it up.
Data being extracted is mainly like wordings, like you want a specific type of wordings you want from the movie.
Sorry?
So in extracting this data set, are you going for a specific type of words? Because I'm not familiar with LLM. Do you go strictly for a type of words you're extracting as a data, or you just say, analyze this data set and give me, analyze this movie and give me a data set? How does it really work for you to have a data set in terms of wordings?
In terms of what, sorry?
You know,
basically the screenplays or the script that you used, was it just a direct screenplay, or was there any additional level of pre-processing or post-processing done once you had extracted that data before it is fed to the model? Before it's given to the model? Yeah. So we downloaded, as I said, the data from Apple, and that's, you know, as I mentioned, it has, you know, timestamps and all sorts of things. And we essentially removed those timestamps and symbols that we thought would be a nuisance for the model. And then that was it. We provided that information to the model. And in terms of the context input, we essentially just joined together the persona, the simple content at the end. You're a 20-year-old professional female, blah, 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 write a positive movie review. For this movie, here's the script.
Brendan, just since we are already on the screen in GitHub repo, could you just point to the data folder and just show maybe an example?
An example of?
of the data, the way the screenplay is, the
Yeah.
original and the cleaned, yeah, which you already have it here.
It's hard to see it because it's just
It's too large.
but that's it. That's the cleaned
So it's basically a novel at this point.
sorry.
It's a novel.
It's a novel.
Yeah.
Yeah.
Oh, okay. Oh, cool.
Yeah. It's yeah.
Yeah, so it doesn't have time information basically.
Okay.
And doing this was not that time consuming. The time consuming part was the actual analysis with the
Yes, the time by far the most time consuming part was waiting for the model to generate the review.
Yeah, because it did already exist. Yeah.
Yes.
Yep. Could you also show? Do you have like a PDF file of the original screenplays and subtitles? So what format is it?
So somewhere
Screenplay files.
All right, I see CSV files. Okay, great.
PDF.
Oh, this is
All right. This is yeah.
So
Right.
that's the original PDF.
Right. Excellent.
yeah.
I think this is a fantastic project, and I'm glad that somehow God gave me this idea, and I kind of attracted a really great team in doing this. And I think if you see the content of the GitHub repo and the paper itself, which is also on archive, uh, it's a pretty well written paper. It's very comprehensive, and there's a lot of work done in here. And this really paves a way for our AI for cinema and music theme. And we look forward to more discussions and contributions from our core members in this theme, and looking forward for the authors and co-authors to be part of our group and help us in brainstorming future projects. Thank you so much, Brendan.
Thank you. Thank you, John.
See the extra screenplay.
And I would just recommend everybody to see these movies, and they're pretty good movies. Yeah.
Which one's your favorite, Rohit?
Which one do you recommend?
Okay. Just click on the names, please, again. So right. So what are the movies we're looking at? All right.
Titanic.
Yeah. I think Shawshank Redemption, of course, is in IMDb the number one movie, and from this list, that would be my favorite. But my all-time favorite from IMDb, the top 250 list, is The Green Mile, actually, which is also written by the same writer who wrote The Shawshank Redemption, Stephen King. And but The Green Mile, I think, is a wonderful movie. I mean, I I, I should have asked you guys to include it, but anyways, we wanted some movies that are kind of out of Hollywood, and Crouching Tiger, Hidden Dragon is what we had included in this one. And in the future, we would like to um, replicate this study to non-English movies, Indian movies, or more Asian movies. And how the reviews are happening there. So Indian movies, for example, there's a top 250 IMDb Indian movie list. And the interesting part there in the IMDb reviews would be, because when you say Indian, it's we are looking at 14 different languages of movies, so 14 different cinema houses, and the top 250 list has significant number of languages. And the way people write reviews, because the languages are different, is something. The other thing that is pretty interesting that I think would like to do from the Indian movie perspective, which is not that much, it's not in Hollywood, that thing where you have like a movie made in for example Tamil or Malayalam. For example, Drishyam was made in Malayalam, then it was remade in Hindi, Tamil, Telugu, and all these languages with different actors and different directors made it. So And in IMDb, they all have different entries with different IMDb ratings and reviews, and the screenplays are slightly different. So I wonder how LLMs would make reviews of those. And one of the other things that we like to probably look into as the future work is more multimodal review analysis. So rather than giving LLMs just the scripts, probably give them the whole movies. And this is Gemini-3 and the future LLMs and AI. So it processes the video and is kind of these nitty-gritty details like make a huge impact on movies, because just subtitles and screenplays, you see there's a number of quite a bit of variations, but when you have the visual information, which is the cinematography, that makes a huge impact in the movie. So for example, a movie such as The Good, the Bad and Ugly, that is I mean, there's not great dialogues in the movie, but it's a western, and it's the number one western movie of all time. So I would recommend you to see it. And the best of Clint Eastwood, of course. And it's more about the timing of the action scenes, how the camera focuses, and that's what all the screenplay is about. But I guess the screenplay gives you far much more information, of course. But when you have the visual scenes coming in, and if LLMs can see that aspect, multimodal LLMs, then that would be pretty interesting. So there's a lot of things to be done in this theme in our group, and looking forward to it. Thank you, everybody. Excellent work.
So that's his hand raised,
Thank you.
or is it just a mistake?
Anybody has anything else to say, or else we probably can
I
end the
I was going to jump in actually, Rohit. I had one more sort of point I wanted to make. I think an interesting thing to look at some point here would be actually to do testing that's definitively out of sample, by which I mean when you look at the dates on these movies and the actual text content, it's basically a certainty that reviews of these films are actually in the training data for the LLMs that are producing these movie reviews. So it would be really interesting to look at comparing against movie reviews for films that have just come out, where you know for sure that the review data has never been in the training data, to see if you sort of sustain the same levels of performance.
Yeah, that's something I was also wanting to point out. Thank you for reminding me, John, that most of these reviews from IMDb would already be in the trained LLM.
Yeah. That is a good point.
We are not really sure about that. That's something to investigate, actually. If the LLMs actually, I mean, the IMDb reviews have been part of the LLM's training data. I think probably in the revision of the paper, that's a thing that we need to address in the discussion section, Brendan, probably. And
yeah, I mean, I guess you could say even if it's not the IMDb data specifically, it's in the training. You know that these are large films that have been around for long. There's just no way that any of these GPT models have not been trained on text that includes discussion of these films.
yes, I think mostly like these GPT models, they have used newspaper sources, and newspapers have a fair amount of reviews when movies come out. So
and they use Reddit. I mean, everything's discussed on Reddit.
yeah. All right, thanks. So I guess we can then end the session. Those guys who are there, have a good time having some drinks, I guess. And I'll see you later. Thank you, everybody. Bye bye.
Yeah.